Okay, so we're going to be graphing in our day 4 notes. We're graphing cosecant and secant. We graphed them for the first time last class, but we're going to graph transformations today. So we're going to start with your parent functions. What is the reciprocal of cosecant? Sine. So we're going to graph sine, and we're going to graph sine in order to help us find our cosecant. So the period of sine is 2 pi. And we have pi, pi over 2, and 3 pi over 2. And on your y-axis, you want to mark 1 and 0 and negative 1. Okay, and then you're going to graph your sine points here, here, here. And you can do your sine graph really lightly, but remember you're going to end up erasing it in the end. So wherever the sine has a 0, the cosecant has what? Asymptote. So graph your asymptotes in a different color, or darker at least. So wherever the sine has a 0, the cosecant has an asymptote because they're reciprocals. And then you find this maximum value on this sine, and you flip the curve so the curve stays inside the asymptotes. And you'd find this minimum on the sine, and you flip the curve there too. Now these branches can't be just floating around anywhere. They need to share the point here at 3 pi over 2 comma negative 1. And they need to share the point here at pi over 2, 1. And this continues forever and ever. So your domain is everything except for the asymptotes. Who remembers what we would write? All reals what? Go ahead, June. Wait, we're trying to say the numbers that are the asymptotes, remember?
Oh, sorry, asymptotes. Okay, so it'd be just k pi or pi k.
Right. And you're going to see it written both x does not equal pi k or x does not equal k pi. Some people like it one way, some like it the other way. It's fine either way. You're just saying pi times k or k times pi. All right, so everything except for the asymptotes. And the asymptotes are 0 pi, 1 pi, 2 pi, 3 pi. They're all multiples of pi. The range is negative infinity up to what? Negative 1. And then it starts up again at 1, and it goes to infinity. All right, any questions on cosecant? Okay, the secant graph is very similar. It depends on the cosine graph. So cosine. And I'm going to have the same values on my axes. Pi over 2, pi, 3 pi over 2, and 2 pi, 1, 0, negative 1. But cosine starts high. So it's going to go up, then midline, then down, then midline, and then up. Oh, and you know what? I never went back and erased these dots from my sine. So remember that those dots from the sine are not actually part of the graph. Okay. So where is the first asymptote I'm going to graph for secant?
At pi over 2.
Very good, because that's the 0 for the cosine. So you have an asymptote here, and you have another one here. And you can continue your cosine if you want to see a full branch. That's a half branch there, and that's a half branch there. But you can continue it if you don't like the half branches. And you do that, and that. So the domain is still everything except for the asymptotes. All real numbers, x does not equal. But where's the first asymptote?
0.
Yeah, the first one's at pi over 2. And then how long between asymptotes? Yeah, this is a distance of pi. So every time I add pi, I'll get to another asymptote. So x does not equal pi over 2 plus pi k. And the range is the same as before. Negative infinity to negative 1, and 1 to infinity. And you can go ahead and erase the cosine graph, because that's not really part of the graph. Okay. All right, any questions on the parents?
would take a parent to like help us on like a test or like a quiz,
Uh-huh.
and we don't erase it, like would that be any problem?
Technically it's wrong, but if you at least use a different color, then I could tell the difference, okay?
Okay.
Yes.
Why is the why is it pi over 2 plus pi k again? Like the pi over 2 part?
Okay, so when I say the domain, I'm trying to say everything except for the asymptotes. Because the domain is everything except for those places. So this is describing the asymptote. So pi over 2, there's an asymptote there. And then if I want to tell how to get to the next asymptote, I would have to add pi to pi over 2 to get to 3 pi over 2.
Okay.
And then the next one is going to be at 5 pi over 2, and I get that by adding another pi. So every time I add pi, I get to another one.
So does the secant have a 2?
Yeah. It's the secant, the first one's at 0, and then every time I add pi to that, I get another one. So this one's 0 plus pi k. Sorry, the cosecant is 0 plus pi k, and then the secant is pi plus pi k. All right. So transformations. Some of you tried these already, which is super. The helper here is sine. And which way does the sine go? Right, yeah. So if you did this already, let's see if you did it correctly. You were supposed to shift right pi over 2. So then pi, 3 pi over 2, 2 pi. And because I'm starting right, I need another one over here. So what would be my next place over here? Who said that? Nice, that's right. Okay, 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. And I need to do a sine, so it's going to be middle, up, middle, down, middle. Okay. All right. If you haven't done this one yet, you should be working on it right now. And then once you have your sine built, that's going to tell you where to put your asymptotes. So put your asymptotes where? Where's the first one going to go? Pi over 2, pi, 3 pi over 2, 2 pi. Where should I put an asymptote? Pi over 2, because that's where we hit the midline. Okay, so everywhere where the sine is on the midline, the cosecant has an asymptote. And then you take this local maximum and you flip the curve up. And you take this local minimum and you flip the curve down, and then you can get rid of your helper, the sine. Okay, so take a second now, if you haven't filled in domain and range, to find your domain and range. It's probably similar to something else that we've done before. X is all real numbers. X does not equal pi over 2 plus pi k. And then the range didn't change. Negative infinity to negative 1 and 1 to infinity. All right, so did you see what we did there? We changed the sign. We didn't have to do anything to the cosecant. So all you're doing is changing the sign and the cosine. Can I turn the page? Okay. So on the next page, if I have a secant, what am I going to graph first? Jaden? What am I going to graph first?
You're gonna graph the secant. Or sorry, the cosine.
Yes. So we're going to graph cosine, and a few things change here. What does the 2 change, guys?
Period.
The period. So the period is 2 pi over 2,
Pi.
which is how much?
Pi.
Pi, yep. All right, so that means we're going to end here at pi. And then label your axes. I've got pi over 2, pi over 4, 3 pi over 4. And what does this plus pi over 2 do?
Move it to the left side.
Left pi over 2. And then the plus 1?
Up 1.
Up 1. So since I have to go left, I better put the negative pi over 2 here, and the negative pi over 4, and then the up 1. So I'm going to pause for a second and ask you guys to draw the cosine in if you haven't done that yet. Draw a cosine that is shifted left pi over 2, up 1, and we've already changed the period. So just the cosine for now. We'll do the secant in a second. All right, so do you start 1 above right here? Yeah? and then midline, down, midline, up. So this is the cosine, like this. Okay, so then wherever your cosine hits the midline, that's where you're going to have an asymptote. Okay, so notice now that your midline has changed, I'm looking to see where does the cosine hit the midline. That's my asymptote. And then I'm still going to flip these points. So this is going to go like that. And then this piece comes down here. No. All right, and this is the first time we have a different domain. We've been having the same domains for all the asymptotes. There were really only two choices. So it still starts with all real numbers x does not equal, because we're trying to describe the asymptotes. Where's the first positive asymptote?
5, 4.
Pi over 4. So x can't equal pi over 4. And what's the distance between the asymptotes? So if I'm going from pi over 4 to negative pi over 4, basically that's twice the distance, right? So pi over 2, yeah. So plus pi over 2 times k. So the first number, it could really be any asymptote, but I usually pick the first positive asymptote. The second number is the distance between the asymptotes. And I just said that on the recording, so if you feel like you need to hear that again, it will be on the recording, okay? Well, one way to find distance is to subtract, okay? So I could subtract pi over 4 minus negative pi over 4, which turns into plus positive, right? And that gives me 2 pi over 4, which is pi over 2.
Oh,
Okay? All right, for the range, this time it's negative infinity up to what value?
0.
Up to 0, good. So notice that our range changed this time. Negative infinity to 0, and then starts up again at what number? 2. All right, I'm going to save 5. I know some of you have already done it, but if you haven't done 5, we're going to do that one after 6. 6 is a little bit different, though, because 6 is the only problem that we've done so far where the b value is not already factored out. So I'm going to 6, and then we'll come back to 5. Okay. In 6, I have a secant, and then my b is not factored out there. The b should be there, and then it would be x minus c plus d. But it's not factored out, so I need to fix that before I know what my c and my d are. So if I want to take the 2 out, I would have 2 times x minus...
what do you mean by it's not factored out?
Do you see how the 2 is not outside of the parentheses?
X minus pi.
Okay.
All right, so what do you guys think of that? X minus pi over 2. If I distributed the 2, would it get me back to where I was before? Yeah, but I don't want to distribute the 2. I want to leave it factored so that I know how much my c is. Minus 1. So 1.5 secant. 2 parentheses x minus pi over 2 minus 1. All right, so now that I have that factored out, there's still a lot going on in this problem. Let's find our period first. What's the period going to be?
Pi.
Good. 2 pi over 2 is pi. So put that here. Negative pi. Do you guys remember that I told you to fix this to be a minus 1? Remember we did that before we started? Also, guys, just to point out, I told you to fix problem 5 also to take off your d value entirely for problem 5. Remember that? Okay. Sorry. Otherwise, it was going to go way off the graph, which would not have been fun. All right, so it's minus 1, so I'm going to put my midline right here. And it's shifted which way?
To the right pi.
To the right, but not pi. Go back to the
Oh, pi 2.
pi over 2. Good. All right, so the helper for secant is cosine. So I'm going to start not 1 above, but how much above? 1.5 above, then midline, and then 1.5 below. And then I ran out of space, so I'm just going to go backwards. I'm going to go back to the midline here, 1.5. Yeah, I think that's right. So this one here is my start point up here. This is where I started. I just wrote start, so I remember where it was. Okay, and now I'm just graphing the cosine here. And then everywhere where I hit the midline, I have an asymptote for my secant. And then take these points and flip the curve. It should be getting closer to your asymptote. It's kind of hard for me to draw in here. But it never actually hits your asymptote.
Wait,
Yep.
the green line, does it go up, middle, down?
So the green line, it started right here. Because I shifted it right pi over 2, so it started up, yeah. And then middle, and then down. But then I ran out of space, so I went back the other way.
Okay.
And then I'm going to erase. Nope, that's not what I want. I want to erase. Okay, my domain, I have an asymptote here at pi over 4. Oops, I want to do that in blue. Pi over 4. And I have another asymptote at 3 pi over 4. So my domain, I'm going to write it over here because I'm running out of space. Domain is all real numbers. X does not equal, what's the first one?
Pi over 4.
X does not equal pi over 4 plus, what's the distance? Pi over 2. Okay, so that's the domain. The range is negative infinity up to what? Oh yeah, I forgot that it wasn't a whole number. It's right there at negative 2.5. Thank you. And then it starts up at what number here? 0.5? Okay, and we shifted which directions? Right, how much? Pi over 2. And up or down? Oh, down. Down 1. Okay, so some of you have done 5. If you've done 5, you can just hold on to it until we're about to go over it in about 5 minutes. But if you haven't done 5, I want you to try 5 on your own. If you're waiting on everybody, then you can start on that homework assignment. It's a little bit long, but we also have SS tomorrow to work on that homework assignment, okay? So make sure you bring that back. So I'm going to pause here for a second while you guys work on 5, and then we'll go and see if you did it right. Okay, so we're going to do number 5 for cosecant. What's the helper? Sine. So we're going to graph 3 sine x plus pi. There's no change in the period, so this is 2 pi. This is pi, pi over 2, and 3 pi over 2. And we're shifting which direction?
To the left pi.
Left pi, good. So I need some negatives as well. I need negative pi over 2 and negative pi. And my sign will go on the midline, and normally it will go up 1, but because of the amplitude, how many does it go up? 3. So it goes up 3, then midline, and then down 3, and midline. All right, so this is just my sign. Then wherever your sign hits the midline, what do you have?
You have the asymptote.
Asymptote, good. Asymptote here, asymptote here, asymptote here. Then take your local maximum, use that point and flip the curve. Take your local minimum and flip the curve. All right, your domain is all real numbers. X does not equal what? K pi or pi k, your choice. And the range is going to be, I'll write it over here, negative infinity up to what?
Negative 3.
-3. And then 3 to infinity. And we said we shifted left pi. Okay. So please use the rest of your time to start working on homework, and if you need me to shift to a different graph, I will do that.